Okay, so let's start. Good afternoon, everybody. So what I want to do today is, last time, guys, I started to explain shift and rotate instruction. I didn't start to rotate, but at least I started this section. I finished shift instructions. I explained what I mean by shift. Okay, so as you see here, guys, shift means, first I said we have two types of shifts. You can shift right, you can shift left, or you shift right. Depends on the direction. That's number one. Number two, for every shift instruction, always you shift with 0. So you put 0 here, and the last bit has to go to the carry. Is that okay? And I explain the instructions we have, and I summarize them here. So these are all the instructions we have for shift. We have two types of shifts. We have logic shift and we have arithmetic shift. So if you look here, what is the difference between them? There is one small difference, and there is a reason for that. I'm going to explain it today. Okay. So if you look here, guys, let me see. So if you look here, how logic shift left is working, as you see here. Look here at this one here. Okay. Let me make it in. Yeah, this is how logic shift left is working. Okay, let's look at how the arithmetic shift left is working this way. They are the same. They are the same. That's what I told you last time. In case of shift left, arithmetic and logic are the same. What do you mean by the same? As you see here, I shift with 0. Okay, last one has to go to the carry. So in case of left, logic or arithmetic are the same. Okay. Maybe, I'm not sure, you need to check. Maybe they change the flags differently. Maybe the flags they are gonna change, maybe different flags. That's something you need to check. But as an operation, they are doing the same thing here. Okay. If you look here for shift right, this is shift right. Okay, and this is here shift right here. Okay, so you can see difference between them. In case of logic, we shift with 0, as you see here. Last one go to the carry. Is that okay? However, in case of arithmetic, the difference is here. The difference is here. In case of arithmetic, look here, guys. We don't shift with 0. We shift with the sign bit. So if the sign bit is 0, I'm gonna shift with 0. If the sign bit is 1, I'm gonna shift with 1. Okay, is that okay, guys? Okay, so in all other shifts, you always shift with 0. But this one here, I shift with the sign bit, the value of the sign bit, right? And there is a reason for that. I'm gonna explain it. Okay, so let me finish the shifts before I go to the rotate instructions. Yeah, but let me, because maybe some still didn't get it. What do you mean by shift, or how it works? Okay, I give you here some numerical example, just if you want to understand it better. This is register A is student number 95. This is 95 this way, guys. So when I shift, what shift means, as I told you, 0 is gonna come here. This bit is gonna come here. This bit is gonna come here. This bit is gonna come here, and then the last one is gonna go to the carry. What about the old value of the carry? It's gone because I overwrite it. Okay. Same thing here. If you shift here, this is in case of arithmetic. So in case of arithmetic here, I'm not going to shift with 0, but I'm going to shift with the last bit, as you see here. So in this case, because the same bit is 1, I'm going to shift with 1. So what's going to happen, as you see here, this one is going to come here. Also, this one is going to be shifted here. So you're going to shift with 1. After that, every bit is going to shift it one. Is going to be shifted one position, and the first one is going to go to the carry. So if this is the original value, after shift, I'm going to get this value, and this is the value of the flag. Okay, any questions? Okay, same thing here. This is another example for shift right. Okay, so this is shift right, but this is logic shift right. So in case of logic shift right, you shift with 0, as you see here. So 0 is here, 1 is here, 1 is here, 1 here, and last one is going to go to the carry. So if this is the original value, after you shift one time to the right, this is what I'm going to get. Okay, guys, any questions? Okay, great. So Yeah, so what I want to explain here, guys, before I start to rotate instructions, is I told you last time we can use shift to multiply by 2 or divide by 2, right? And some people, especially the people who are implementing crypto systems, because in crypto system, usually we have very large numbers. So usually what they do, if you wanna divide by 2 many times, this shift can divide by 2 or multiply by 2 efficiently, much more efficiently than using multiplication and shift multiplication and division instruction I taught before, because shift is efficient. So once you shift, you just divide by 2 or multiply by 2. Okay. However, also here we have signed multiplication and division, also unsigned multiplication and division. Okay, so just let me finish this one and then I'm going to come to you. Okay, so what is the difference between them? That's what I'm going to explain right now. Listen to me, guys. So in case of logic shift, okay, this one can be used for unsigned. If your numbers are unsigned, okay, and you want to multiply by 2 or you want to divide by 2, you can just use logic shift in case of unsigned. However, arithmetic shifts, sorry, this mistake. So arithmetic shifts are used in case of signed numbers. Why? Why is that? Give me example. I'm going to give you example. Okay. So for example, in case of if you want to multiply by 2, okay, as you see here, guys, if this number is 1, if I shift this way, I'm gonna get 2. Okay. Actually, it doesn't matter in shift left. In both of them, you are gonna shift. You shift by 0. So let's see the other example here. If this number is -1, when I put 0 here, when I shift with 0, okay, I'm gonna get -2. If I shift again, I'm gonna get -4. So you can see here, guys. You can see here how we can, in case of signed or unsigned numbers. Actually, as I told you, these two are doing the same thing. So if you use arithmetic or logic in case of left, no difference, because in both cases, I'm going to shift with 0 in both cases. You got what I'm saying? So these are okay. So however, the difference is going to come here in case of division. I'm going to tell you what is also the idea. So the idea is that if your number is unsigned, okay, and you want to divide by 2, so in this case you have to use logic shift. You have to shift with 0. Let me give you example, something like that. Here, if I put 1 here, 0, 0, 0. Okay, this is not a negative number, so this one doesn't mean it's a negative number. This is unsigned, so this number 128. Okay, so again, when I insert 0 here, so it's going to become 64. So you divide by 2. You got it? Okay. However, the problem is going to come here. If your numbers are, in case of signed numbers, and in case of signed numbers, and your numbers are negative, okay. If for example, this one is -128. Okay. If you shift with 0 here, you know what's going to happen? What's going to happen if you shift with 0? I'm going to get this number, positive 64, which is wrong. Listen to me, when I say here. This number is negative. When I divide by 2, I have to keep it negative, right? To get a correct value. If I shift with 0, it's going to become a positive number. That's why here, in this case, we are going to shift with the sign bit. If the sign bit is 1, I'm going to shift with 1. If the sign bit is 0, I'm going to shift by 0. Okay, as you see here. So in this case, as you see here, guys, if this one is -128, if I shift with 1 here, so it's going to be -64. Okay, so let me tell you the conclusion. The conclusion is, guys, shift instruction can be used to multiply by 2 or divide by 2. Always shift left is gonna be multiplied by 2. Right is gonna be divided by 2. However, if your numbers are unsigned, you can use the logic shifts. Okay, your number signed, so in this case you have to use arithmetic shifts. So arithmetic shifts are used in case of signed numbers. Yes, what's your question?
So how much more effective at multiplying and dividing is the log logic shifts than just multiplying it and having this. So we can figure out what 5 times the number is by using logic shifts and having that number still, but this is
Shifts are much more efficient than multiplication or division instructions. The operation, because we're not doing anything, you just shift the bits. You get what I'm saying? So it's much more efficient than the operation done by multiplication and division instructions. That's why one of the approaches that people are using, if you want to do like quick multiplication or division, is by using shifts instruction because it's much simpler. Okay, they use it extensively, especially in crypto, when you implement some crypto systems, because in crypto system we have large numbers. So if you want to divide quickly or multiply quickly by 2, shifts is going to help. But as a difference, it's a huge difference anyway. In general, I'm talking in general. Okay, it's a huge difference between using it's not anyway. If you want to do something very quick, shift should be much better. Yes.
Is it possible to do a larger logic shift by a number bigger? So example,
No, I didn't understand your question, but you are talking about you want to do multiple shifts, right? Yes, yeah. So that's what we're going to do in the coming lab, not this week, next week. It's going to be about this. Okay. Yes, that's exactly what I want to say. So if you wanna, that's exactly what we're going to do in the coming lab. For example, if I want to multiply by 8, multiplying by 8 means I have to shift left 3 times, right? Because when you shift 1 time, you multiply by 2. When you shift again, so you again multiply by 2. So both of them you multiply by 4. You got what I'm saying? So you are going to do something like that in the coming lab. So if you want to, same thing, if you, for example, if you want to multiply by 1024, 1024 is 2 to the power 10. That means I have to do 10 shifts, right? Because every shift you are going to multiply by 2. Yes. Yeah, you can, yeah, for sure. If your number is big, for sure. If your number is bigger, it has to be in a word, or this is a different issue. Yes. Anyway, any question, guys? Okay. So now let's come to rotate instruction. Okay. So number 1, how they work? How this rotate work? And why they are calling it rotate? Simply because we rotate. Shift because we shift. It's the same thing. Look how it works here, guys. Again, similar to shift, we have rotate right and rotate left as well. So here again, for rotate, we have left and we have right as well, similar to shift. This number 1. But the main difference, as you see here, for example, this is rotate left. See what I'm going to do, guys, here? Here, in case of shift, I'm going to insert 0 here, and the last one has to go to the carry. And this time, I'm not going to shift, I'm not going to input 0 here. This time, I'm going to input the value of the carry. So I'm going to shift by the carry, as you see here. So the carry is going to come here. What do you mean by the carry is going to come here? What I mean, whatever is the carry. If the carry is 1, so 1 is going to come to here. If the carry is 0, 0 is going to come here. So the carry is going to come here. B1 is shifted. All of them are shifted. B7 is going to go back to the carry. That's why you see it is like rotate. You are rotating. Okay. So after you rotate, so after you rotate 8 times or 9 times, after you rotate 9 times, I'm going to get the same value back. You are not going to lose it. You got what I'm saying? Why? Because you are not inputting 0. So every time you rotate, this one is gonna come here, go back, and then come back here. You got what I'm saying? You rotate. That's why you can see rotate as if it is shift with carry. Yes, that's true. It is like shift with carry. You shift whatever in the carry here. If the carry 1 or 0, you shift with the carry, and the last one is going to go to the carry again. Any question? You see the difference between rotate and shift? Okay, they're almost the same. The only difference here in case of shift, you input 0 here, and the last one go to the carry. But in case of rotate, you input here the carry, and the last one also is going to go to the carry again. Okay. So this is for left, rotate left. We have also rotate right. Rotate right this way. Okay. It's exactly the same thing, similar to this one, but the direction is going to be different. So the carry is going to come here in bit number 7. Bit number 0 is going to come back. After you shift, it should look like something like here. After you rotate, it look like something like this one. Carry is here, bit 7 is here until bit 1, and then bit 0 should be here. Okay. Let's have before I choose the instructions, or let me choose an instruction first, and then I'm going to show you the example. Okay, so let's see what instruction we have here, guys. We have here rotate, ROL, rotate left, and then here you have to put a memory location. We have rotate for register A. We have rotate for register B. Is that okay? And this is for left. Same thing for right. We have rotate, ROR, and then memory location, rotate A, rotate B. So all the rotate instruction are for bytes. We don't have rotate instruction for words. Okay, any questions? Okay, let's see some examples on that. So let's first see the numerical example I have here, just to understand better how it works. Okay, so if you see here, guys, we assuming this is register B. Use a different color here. Okay, this is register B is storing this number BD. So this is BD is stored here. Okay, and the initial value for the carry is 1. Okay, the initial value for the carry is 1. The carry is 1 here, as you see, guys. And then I wanna do rotate left. So I'm gonna rotate this way. How rotate is gonna work, guys? I told you it's very simple. It's similar to shift with carry. So what's gonna happen? Every bit is shifted here. Every bit is shifted, and the last one here is gonna go to the carry, and the old value of the carry should come here, as you see here. So what's gonna happen? As you see, this is the carry here. 1 is gonna come here. This one come here, and then until this one come here, and this bit has go to the carry again. Is that okay? So after you do, if this is the original value, after you do the rotate, that's what you are gonna get. Okay. Any questions? I have another example for rotate right. Rotate right here. In rotate, don't be confused. In rotate, we don't have logic and arithmetic rotate. No, we don't. Only rotate. Okay. So let's see here in case of rotate. Here we rotate right. So I have to rotate this way to the right. So what's going to happen, as you see here, guys, every bit is shifted 1 bit. Every bit is shifted 1 bit. And then the last bit here, which is 0, is going to go to the carry, and the carry is going to come here. Is that okay? So the carry is 1. The carry is 1, so I'm going to shift it by 1. So the one is going to come here. Every one is shifted. The original one is going to come back to the carry. Okay. So if this is the original value before you rotate, that's what you are going to get after you rotate. Okay, any questions? Okay, guys. So, and next week there will be a quiz on shift and rotate instruction. In this quiz, I'm gonna give you some question like this one. So I'm gonna give you some value. I'm gonna ask you to rotate or shift, and then I'm gonna tell you after you rotate or after you shift what is the value. I just want to make sure you understand how these instructions are working. Okay. Any questions? Okay. Now let's have another example here, guys. What I want to do, guys, here is I want to count. I want to write a program. I want to write a program to count the number of zeros in 16-bit register G. I want to see how many bits, how many zeros are in this register. How many bits are zeros? I want to count how many zeros in this register. Is that okay? How can I do that? Look at the idea. The idea is, okay, if this is register D, for example, just an example, if this is register D is storing this number. Okay, look at the idea. So what I'm gonna do, if I shift one time to register D, if you shift one time, what's gonna happen is this bit is gonna go to the carry. Is that right? So when I shift one time, this is the first bit. This bit is gonna go to the carry. And then I can ask the carry, are you 0 or are you 1? If the carry tells me I am 0, so I'm gonna increment the counter. Is that okay? Now I have to next time, now this bit is gonna be the first bit after we shift. So when I shift again, so this bit is gonna go to the carry. And ask the carry again. After another shift, this one is gonna go to the carry. This one is gonna go to the carry, and so on. You got what I'm saying? So as you see here, guys, in this example, here after the first shift, so this bit is gonna go to the carry, so I'm gonna check it. Then another shift, so this one is gonna go to the carry. Another shift, this one is gonna go to the carry. This one is gonna go to the carry. This one is gonna go to the carry. And every time I'm gonna ask the carry, are you 0 or 1? If the carry is 0, I'm gonna increment the counter because I wanna count how many zeros we have. Is that okay? So let me ask you a question. How many shifts I have to make? Can anyone answer me? How many shifts I need to make? Yes. That's true. So I have to make shifts because every time I do one shift, I'm gonna get one bit. And in case of register D, we have 16 bits. Is that okay? So the way I'm gonna do it is I'm gonna make full loop. So number one, I'm thinking how I can solve the problem. So here what I'm saying, number one, I have to make full loop for 16 iterations. Okay, this number one. Number one, I have to make full loop, right? In every iteration, number one, I'm gonna shift. Number two, I'm gonna check carry, if the carry is 0 or 1. And then based on this value, either I increment the counter or do nothing. If the carry is 1, do nothing. If the carry is 0, increment the counter. Is that okay? Okay, great. Let me ask you another question. Does it matter if I shift right or I shift left? Does it matter? It doesn't matter because if you check from here to here, it's the same. I'm gonna get the same result if I check from here to here. Is that okay? So it doesn't matter if you shift or right or left. Yes. Yes, you can do that, but maybe it's easier to just okay. So what you want to say is, can I count first the number of zeros in register B and then go to register A, or count A and then B? The answer is this. You can do that. However, programming wise, it's going to be much easier if you work on register D as one unit. Programming is going to be much easier, right? Because if you wanna work on two different bytes, so you have to make two full loops 8 times and then another one 8 times. Or it's gonna be more complicated. But yes, you can. Yes. Take again one loop. How many times? 16 times. So one loop 16 times. Oh, no, you're right. So you can make it one loop and then you shift A and then you shift B. You can do that. Yes, you can do that. However, it's like it's easier to work on register G. You get what I'm saying? I'm not forced because I have another option, easier option, right? I can do that if, for example, in case of if I want to rotate. Why? Because shift is gonna destroy the number, because after you shift you're gonna get 0 0 0 0. So for example, if you want to use rotate, and because I don't have a rotate for a word, so in this case, okay, so I'm gonna do rotate here and I do rotate here because I don't have rotate for a word. Yes. Okay. So let's see. So this is how I should think about the problem. Number one, as I told you guys, let me show you how I solved it. Look here, guys. Number one, I have to make full loop 16 times. Yes. How can you do that? You have different ways. I already explained before different ways to do that. So I decided, because I always like to use memory location instead of register. I like to do that. That's why here I made I'm gonna use a memory location to make for loop 16 times, as you see here. This is the body of 4. Forget it for now. So forget this part. This is the body of 4. So as you see here, guys, what I did here is this is a counter. This is a counter for the loop. I initialize it to 16, as you see here. In every iteration, I'm going to decrement it. Okay. A branch, if not equal, if it is not equal 0, go back. If it's not equal 0, go back. Once if it is equal to 0, I'm going to leave here. Okay, guys. By this way, I'm going to make for loop 16 times. By the way, I didn't use compare here. I didn't use compare here because I guess you can check, but I guess decrement should update the 0 flag. So when you decrement and the result is 0, so this one is going to update the 0 flag. That's why in this case I do need to compare. If it doesn't, if decrement does not change the 0 flag, in this case, this is not true, and I have to add compare here. After you do it, so you have to do something like load register A and the loop counter, and then I have to compare A to number 0. I have to put something here. Okay, anyway. So by this way, guys, I was able to create a for loop for 16 times from here to here. Any questions? Okay, now, what should I do in every iteration? Number one, I have to shift. As I told you, that's exactly what I did. So now, number one, you have to shift. Right or left, it doesn't matter. Shift. Okay, that's number one for register D. Number two, after you shift, I'm gonna get one bit. I'm gonna put one bit. I'm gonna put it in the carry. Then after that, I'm gonna check the carry. Right. So I'm gonna say here, guys, branch if carry is set to next, to skip this one here if the carry is 1. So if the carry, as you see here, guys, if the carry is 1, so I want to skip this one. Okay. If not, so I'm going to come this way to increment the 0 count. Is that okay? Any questions? You have a question? Okay. So now let me ask you a question. What if I want to count the number of ones instead of number in 0? How I would modify this one? Yeah, this is just one letter, right? So instead of S here, we would C. So what I'm going to say here, please jump to here if the carry is equal to 0. So if the carry is 0, jump. If not, if the carry is 1, it's going to come this way to increment the counter. Okay, guys, is that any questions? Okay, let me also tell you something. Okay, it looks interesting program, but tell me why, if I have a byte or if I have a word or a byte, why I want to count the number of ones or number of zeros? Give me an application. How this can be useful in some application? Okay, I'm going to give you, for example, just one quick. For sure, there may be different reasons to do that or different application, but maybe I'm going to give you something very quick. Okay, for example, here, guys, as I'm going to teach later in this course, if you have the microcontroller, maybe you have here pins. These pins, you can connect it to switches. Okay, so for example, if I want to make something like a voting system, voting system. Okay, so every person has a switch to select yes or no for voting. Is that okay? So in case, for example, in case of no, so I'm going to get 0. In case of yes, I'm going to get 1. So when you read, you cannot read individual bits. You are going to need a complete byte. So what's going to happen here, guys? I'm going to have a complete byte. This byte has 1s and 0s. Where, for example, 0 means no, and 1 means yes. And now I want to count how many number of yes votes and how many no votes. You got what I'm saying? This is just one quick example. Maybe these 1s and 0s are coming from sensors, for example, and I want to see how many sensors. I want to see the majority. So the majority think is that there is a problem in the machine, or there is a security threat, or whatever. It depends on the application. You get what I'm saying? So it's coming from different sensors, whatever, something like that. Anyway, so I just want to give you one quick example. How can you use this program in some application? Any questions? Okay, guys, very easy. So let me explain what I did so far before I move forward, because this section is very easy. So what I did so far, guys, I summarize all the instructions here. I finished this instruction here, guys. Yeah. So as you see here, guys, I explained shift instructions, left, logic and arithmetic. Also, I explained rotate instructions. Okay, rotate left and rotate right. You should know how they work. Okay, because that's what we're going to use in the coming lab. The coming lab is going to be about shift, rotate, and Boolean logic operations. I'm going to explain the Boolean logic operation now. Okay, so you need to know how they are working, and then we are going to have one lab on this one and also a quiz. Any questions? So the next topic I'm going to explain right now, guys, is, oh, I think I missed this one. Let me explain this example before I move forward. Okay. Yeah. Maybe, okay, let me explain this example as well. So look at the idea here, guys. For example, if I want to make shift left or right, for example, if I want to make shift right, guys, for a byte, so it's easy. I have one instruction to do shift right for a byte. Okay, if I want to do it for a word, that's easy. We have an instruction to do it for a word. Is that okay, guys? Now, what if my number is double word, and I wanna shift right? Okay, or maybe bigger than, for example, 70 words or 10 words. So if I have a very large number, okay, so can I do shift to this large number? The answer is yes, you can do. But you cannot do using one instruction, because if you want to use one instruction, you can do, just give me 1 second, you can do byte or you can do word if it is one instruction. Sorry, but in this case, I have to use multiple instructions. So look at the idea how I'm going to do it. So here I'm assuming I have a very long number, as you see here, guys. So if I want to shift this number, so what I'm going to do is the following, as you see here, guys. I wanna do shift right. So I have to start from the most significant byte if you want to do right. If you want to do left, so you have to start from the least significant. But anyway, I'm gonna do right. So what I'm gonna do here, guys, as you see here, I'm gonna do shift. So this one is gonna go to, so the first one is gonna be shift, but all the other ones are gonna be rotate. Why? So listen to me. What I'm saying, if you have here a large number, for example, 100 bytes, 30 bytes, something like that. Okay, it's a bigger than a word. Okay, I don't have an instruction to shift more than a word, but still I can do it. Okay, you know how I'm gonna do it? I'm gonna tell you how. Look here. The first one is gonna be normal shift. So this is shift right, normal one. So this one is gonna input 0 here, and the last one is gonna go to the carry. Is that okay? And then after that, so I'm gonna use shift only one time, the beginning. After that, I'm going to use rotate. Why? Because actually rotate is shift with carry. So what's going to happen is that, look here, guys. Here, when you rotate, you shift with the carry. The carry is storing the last bit here. The carry is storing this bit. So when you rotate with carry, so what's going to happen? This shift is going to, the last one is going to go to the carry. And then rotate with carry is going to input the carry here. You got what I'm saying? Same thing here. When this one is going to go to the carry, and then we rotate with carry, I'm going to input the carry here, and so on. So always when you do here, when you rotate with carry, so this one is going to go to the carry, and then I'm going to input it here. Okay, that's how it works. So the first one I'm going to do shift, and then after that I do rotate. Okay, so if you want to here in this, I give you one example here. So number one, you do shift, and then you do rotate. Okay, so these 4 instructions are going to do one shift operation for 32 bits. Okay, so if you want to do several shifts, if I want to do multiple shifts, okay, so I have to repeat. I made full loop here. I have to repeat this part, because these 4 instructions are going to make only one shift operation. Yes. Okay, great. So you can see this idea is very close to add with carry, subtract with borrow, as I explained to you before. It's the same idea. You got what I'm saying? So again, the idea is the first one will be normal shift, the first one. So the last one here is going to go to the carry. And then I'm going to do rotate. Why? Because rotate actually is shift with carry. So every time I'm going to shift with the carry. So last one is going to go to the carry, shift with the carry. Last one is going to go to the carry, shift with the carry, and so on. Okay. Any questions? Great. So now I'm going to move to the next topic. In the next topic, I'm going to explain Boolean logic operations. Okay. So what do you mean by Boolean logic operation? You know what you already know from the digital system what this means. It means we want to do bit by bit or bitwise, bit by bit logic operation, bit by bit. Okay. So, and what logic operation we have here? Okay, we have AND, we have OR, we have XOR, bit by bit. So if you have two numbers, I can do bit by bit logic operation. AND 1 and 1, 1 and 0, 0 and 0, and so on. So bit by bit. Okay, AND or 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 XOR. Okay, guys, any questions? So we have an instruction to do that. So what I'm going to explain right now, number one, I'm going to make a very quick revision how AND works, how OR works, how XOR works. Is number one. Number two, I'm going to teach what instruction we have. So we have instructions to do Boolean logic operations. I'm going to explain this instruction. More importantly, I'm going to explain how we're going to use them. Very useful. So these ones are much more useful than shift and still shift and rotate are important. Okay, but this one maybe we are going to use it more in this course. Okay, so let's make a very quick revision on AND, how AND works, and then after that we are going to guess. You are going to guess from here. We are going to guess how can we use them in this course. Okay, look here, guys. This is how AND. This is the truth. You know the truth table, right? So this is how AND works. Look here. AND works this way. If you have a number X, and this number binary number, so it can be 0 or 1, it doesn't matter, 0 or 1. Okay, 0 and any number, any other number, the result is 0, regardless what this number is. This is how AND works, right? So 0 and 0, I'm gonna get 0. 0 and 1, I'm gonna get also 0. Doesn't matter. Okay, so this is how AND works. So AND is telling me if one input is 0, regardless of the other one, I'm gonna give you 0. This is how AND works. Okay. Also, if one input is 1, I'm gonna give you if one input is 1 and the other input is 0, X, I'm gonna give you X. What this means? It means if X is 1, I'm gonna get 1. If X is 0, I'm gonna get 0, as you see here. Okay. So this is how AND works. So again, AND work is this way, guys. If one input is 0, I'm gonna get 0 regardless of the other input. This is number one. Number two, if one input is 1, I'm gonna get the output here is gonna be equal to the other input here. So the output here is gonna be X, similar to this input here. Okay. Now let's look how OR works. OR work is this way, guys. If one input is 1, I'm gonna give you 1 regardless of what is the value of the other one. Okay. So if one input is 1, the result is 1, regardless what value is here. Okay. But if one input is 0, so the output of OR should be equal to the other input. So this one should be X. Again, that means if this one is 0, I'm gonna get 0 here. If this one is 1, I'm gonna get 1 here. Is that okay? Now, how XOR is working? I'm gonna tell you how XOR is working. As you see here, in XOR, guys, if one input is 0, the output is going to be similar to the other. And this one is X. Again, X can be 0 or 1, it doesn't matter. Okay, so I'm going to get here X. But if one input is 1, so I'm going to get here X prime. X prime is a complement of X. That means here, if I have 0, I'm going to get 0. If I have 1, I'm going to get 1. But here, if I have 0, I'm going to get 1. If I have 1, I'm going to get 0. This is how they work. Okay. Again, I'm going to say it quickly before we move forward. So, and logic AND is telling me one input is 0, the output is 0. One input is 1, the output is X, as you see here. Or one input is 1, the output is 1. One input 0, the output is X. Or when one input 0, I'm gonna get X. But when one input is 1, I'm gonna get X prime. Is that okay? This is how it works. Now, more importantly, before I give you the instruction, very important. What I'm going to teach right now, very important, because we are going to do it all the time. All the time we are going to do it, guys. Listen to me. Why or how we are going to use the Boolean operation in this course. Very important. We are going to use it all the time. Actually, Boolean operation can be used to do one of two things. Boolean operation can be used if you want to do bit manipulation. Bit manipulation. Okay. Or they can be used if you want to check some bits. If you want to check some bits, if there are some bits ones or zeros. Similar to branch if clear, branch if set, similar. Okay. So I'm going to show now how can we do the same thing we did before for branch if clear, branch if set, but I'm going to do it right now using logic operation. Okay. However, as I told you before, the main problem in branch if set or branch if clear is that they are short. But if I use logic operation now, I can make it long. So I can check some bits as we did. I can check some bits as we did in branch of clear, branch of set, but using logic operations, and by this way I can create long branches. Okay. As I told you before, why sometimes I need to check some bits? Why sometimes I need to do something like that? Simply because that's exactly what we're going to do in chapter 3. Here, as you see here, guys, we have switches here. We have switches, okay? So what's going to happen in chapter, and these switches are connected to port H. So what happens is that if I want to know a switch is connected or not, you cannot read one switch. You can't do that. What's going to happen, you have to read the whole port. And this port is a byte. So what's going to happen, I'm going to read a byte, a complete byte. Is that okay? And then if I want to check, and again, as I told you before, this is a byte. Every bit here is connected to a switch. So that if the switch is open, so this one is 1. If the switch is connected, so this one is 0. So this is done automatically by the hardware. I'm going to explain it later. Okay. So at the software side, you have a byte. And in this byte, every bit can tell you the status of a switch. So now I have a byte and I need to check. I need to check if this one, if this bit is 0 or 1. Is that okay? So how can we do that? That's what I'm going to explain here. I already explained it using branch if set, branch if clear, but this time I'm going to explain it in a different way using logic operations. Is that okay? So this is what I'm explaining here in that figure. We have an external pin. We have an external pin. This pin is connected to a switch, and somehow the hardware, this pin is connected to 1 bit in a byte, 1 bit in a byte. And then if the switch, if the switch is open or closed, so I'm gonna put here 0 volt or 5 volt, and here in the software, you will find here logic 0 or logic 1. Is that okay? So at the end, if you want to know if the switch is connected or not, you have a byte and you need to check some bits, maybe 1 bit or whatever. So you're gonna check one switch, so it's gonna be 1 bit. Is that okay? I'm telling you why sometimes I need to check some bits in a byte because of this reason. How? That's what I'm going to explain in this section. I already explained one way using branch if clear, one branch if set, but this time I'm going to explain another approach. Okay. The second thing we're going to use logic operations for is by doing bit manipulation. Bit manipulation. What do you mean by bit manipulation? I don't understand what this means. I'm going to tell you what this means. Okay, look here, guys. You have a byte, and we have a bit. Any bit, can be any bit. For example, I selected this bit, okay? Bit manipulation means I want to clear this bit without changing the other bits. So I want to manipulate 1 bit or maybe 1 or more. But here I'm going to give you an example for 1 bit, right? So I have a byte I want to change one bit without changing the other bits. What do you mean by change? What I mean by change means I want to set a bit, I want to clear a bit, I want to flip a bit. You got what I'm saying? So I have a byte, and I just want to modify one bit in the byte, maybe one or more. But I'll just give you one example. One can be 2 bits, okay? But some bits in a byte, I want to clear bit without changing the other bits. I want to keep the other bits without changing them. But just one bit, I want to clear it, or I want to set it, or I want to flip it. Is that okay? Okay, tell me how. This is what I mean by bit manipulation. You want to manipulate some bits in a byte without changing the other bits. Okay, tell me how this is useful. It's very useful. We're going to use it all the time. Look here, guys. What's going to happen is that you can see here we have in LEDs. These LEDs are connected to port B. As I'm going to explain in chapter 3, they are connected to port B. What's going to happen is that, look here, guys. What's going to happen is that you have here, you have a byte. This byte is called port B, okay? You have a byte. What's going to happen is that every byte is connected somehow to one external pin. When I put in the byte logic 1, the hardware is going to put here 5 volts. It's going to put here, if I put in this bit 0, so the hardware is going to put here 0 volt. You got what I'm saying? And then every pin here is connected to an LED. As you see here, we have 8 LEDs. So if I want to turn on, one LED, so I have to put 1 here in the corresponding bit to turn it on. If I want to turn it off, so I have to put 0 here in this bit. For sure, I don't want to change the status of the other bits or the status of the other LEDs. So conclusion, make it easy. Conclusion is going to happen in this course many times that you have a byte, you want to check some bits to see if they are zeros or ones. It's going to happen a lot. Okay. Why? For example, in case if I want to know the switch is connected or not. Okay. This is one thing. The other thing, it's going to happen a lot in this course, that we are going to do something like a bit manipulation. I have a byte, and then a certain bit or more, I want to manipulate this bit. What do you mean by manipulate? I mean clear, set, flip it. Okay. For example, if I want to make a flashing LED, and that's exactly what we are going to do in chapter 3. I want to do a flashing LED. Okay, so what's going to happen? This bit somehow connected to one LED, guys. All what I'm going to do, I have to flip this bit every certain time. For example, every 1 second, I'm going to flip it. If you do that, you are going to see flashing on for 1 second, off for 1 second, on for 1 second, off for 1 second, and so you are going to see flashing. Because every time you flip, you are going to change the status. So if it's 1, you turn it on. After 1 second, I'm going to flip 1 to 0, turn it off. After 1 second, you flip 0 to 1, and so on. If you keep doing that, you are going to see flashing. Any questions? Okay, so now I'm going to explain what I'm going to explain, guys. Now I'm going to start with bit manipulation. I'm going to explain in case of how can you set some bits without changing the other bits. How can you clear some bits without changing the other bits? How can you flip some bits without changing the other bits using the Boolean operation I explained here, the Boolean operations. Okay, guys. I'm going to tell you very easy. Look here. Let's start. If you want to clear some bits and you don't want to change the other bits, you have to use logic AND. So logic AND should be used if you want to clear some bits. Why? Why I have to use logic AND if you want to clear some bits? Simply because look how it works. Logic AND is telling you 0x, I'm going to give you 0. That's how can you clear. However, the bits you don't want to change, just to put 1 here, you are going to get the same bits again. Let's have example. Example, guys. I have a byte here. I want to clear this bit. I don't want to change the other bits. You know what I'm going to do? Clear means you have to use logic AND. So here I'm gonna use logic AND. Then I'm gonna do AND with what number? I'm gonna put here 0, because 0 and any bit I'm gonna get 0. So now I'm gonna clear this bit. Okay, and then the bits you don't want to change, I have to put ones, because ones are gonna give me the same bits back again. You got it? Here, number one, if you want to clear some bits, you have to use logic AND. Okay, this number one. How I can use it? Very simple. The bit or the bits you want to clear, I have to put 0 at the location of these bits. The bits you don't want to change, you have to put ones, because this is how AND works. If you put 1, I'm going to get the same bit again. If you put 0, I'm going to clear it. Okay, so here, for example, if I want to clear this bit, I'm going to put here 0. I don't want to change those other bits, I'm going to put ones. So 0 and this bit, I'm going to get 0. 1, so I'm going to get the same bit again, the same bit again, the same bit again, and so on. Any questions? That's exactly what I'm explaining here. If you want to clear one bit, for example, I want to clear this bit, and I don't want to change the other bits. So all what you have to do, you have to put here a mask this way. You have to put here 0 under this one, because 0 and anything, I'm going to get 0. And the bits you don't want to change, you just put ones under them, because I'm going to get the same bits again. Okay, so for example, if I do AND with 0, 0, 0, 0, so I'm going to get 0, 0, 0. Actually, you are going to clear A. Is that okay? If you do AND with 0, 0, 0, 1, 1, 1, 1. So this one, so here I'm going to get these 4 bits are going to come here, no change, but I'm going to mask, or I'm going to clear the first 4 bits. I'm going to clear the first 4 bits. Any questions? Is that easy? Any questions? Great. Okay. Now, so again, you told me, number one, now I'm expecting you understand what bit manipulation means. This number one. You change some bits, you don't change other bits in a byte. Okay. This is the meaning of bit manipulation. Number two, I'm expecting now that you understand if you want to clear some bit, you have to use logic AND. Also, I'm expecting to understand how can you do it. How the bits you want to clear, you have to put zeros in the locations of these bits. The other bits you don't need to change, you have to put ones. Is that okay? Also, you understand why you are doing this way, because this is how AND works. So if you see how I explained it here, this is how AND works. If you put 0, you are gonna get 0. If you put 1, no change. No change. Is that okay? Now, how can I set some bits and don't change the other bits instead of clear set? If you want to set some bits, OR is gonna help you. OR is gonna help you. Okay, let's see how. Look, if you see how OR works, guys, 1 and any bit, you are gonna get 1. 0 with any bit, no change. I'm gonna get the same bit again, no change. That's exactly what I want to do. Some bits, no change. Some bits, I want to force them to become 1. That's exactly what I want to do. So the bits, no change, I have to put 0. The bits I don't want to change, I have to put 0 in the location of these bits. The bits I don't want to change. But the bits I wanna set, I have to put 1 here. Is that okay? So let's have an example to see how it works. For example, I wanna set this bit, but I don't want to change these bits. Look here. So now I'm gonna do OR, logic OR, and then I'm gonna put 0, 0, 0, and then I'm gonna put 1 here. 1 or this one, the result is 1 for sure. 0, no change. So I'm gonna get them back. So what I'm gonna get here, guys, what I'm gonna get here is exactly similar to this byte, but after you see this one and then this one, no change. Okay, guys, any questions? Easy. It's a little bit confusing, but you should understand that. Why it's a little bit confusing? Because in case of AND, 1 means no change. 0 means clear. But in case of OR, 0 means no change. You got what I'm saying? 0 means no change. again, because this is how it works. This is not how, this is how it works. 0 and anything, you are going to not change. This is how it works. But in case of AND, 1 and X, you are going to get X. This is how it works, right? Now, let's look at the last thing I want to explain here, guys. Flip. How can you flip some bits? Flip some bits and you don't change the other bits. Again, what flip means? Flip means flip means complement. Okay, so if the bit is 1, I want to make it 0. If it is 0, I want to make it 1. That's the meaning of flip. Okay, so I want to flip some bits. So which logic operation should help you here? XOR. XOR. So again, guys, if you want to clear some bits, you have to use logic AND. If you want to set some bits, you have to use OR. If you want to flip some bits, you have to use XOR. Is that okay? How XOR is working? Because I'm looking for two things. I'm looking for a number that's gonna flip. Also, I'm looking for another number I have to use for no change. That's how exactly it works. Look here. If I put 0 here, the result no change. If I put 1, I'm gonna flip. I'm gonna get X prime. Very simple. So as shown here, guys. So the bits you don't want to change, you have to put zeros in the location of these bits. The bits you want to flip, you have to put 1 in the location of these bits. Okay, guys. So this is, I have an example here to understand it. Okay, for example, I want to flip this bit. I don't want to change the other bits. If you want to flip this bit, you have to put here 1 so that you can get bit 7 prime. If you don't want to change the other bits, you put here zeros. Is that okay? Okay. So now guys, you should, how can you do that? Or I didn't teach it in instructions. I'm teaching. I'm expecting now that you understand what bit manipulation means. Also, I'm expecting that you understand what should you do if you want to set some bits, if you want to clear some bits, if you want to flip some bits. Is that okay? For example, if you have a register A here this way, guys, and then I do XOR, and then I put here 1 1 1 1 1 1 1 1. So I'm gonna flip all the bits. So this one is gonna be similar to complement A, instruction complement A, because you are gonna flip all the bits. Got what I'm saying? Anyway. Now I want to move to the other here. How we are gonna use the logic operation in order to check. Here I want to check some bits, not bit manipulation. I don't want to change bits. I just want to check. I want to check if this bit is 0 or 1, right? Before I already used bit set and branch shift clear and branch shift set. So I already explained this one before. The way I explained it, if you remember, because now I'm gonna teach another approach. So the way I explained it, guys, I told you, for example, you can say branch if clear, and then you have to put here a memory location, for example, 1000. So here I'm talking about this byte, the byte at 1000. Is that okay? Now, then here you have to put a mask, and then you have to put a label where you want to branch. In this mask, I told you the way you have to do the mask is the bits you want to branch, if they are clear, you have to put 1 in the location of these bits, and then you have to put 0 everywhere. Is that okay? That's what I explained before. What I explained before, if you do this way, I'm gonna branch to this location if this bit is 1. And that's what you should do in tomorrow's lab. Okay, tomorrow's lab you need to do something like that. What I'm gonna do right now, I'm gonna explain how can you do the same thing using logic operations. However, what I'm gonna explain now, it has one advantage over what I explained here. The advantages is you can use it for, you can make long branches. This one always short. Branches is always short. Okay, so let me explain how we will do it. Look here, guys. Look at the logic. I want you to understand how we made it. Look at the idea, guys. I want to check if a bit is 0 or 1. I want to check one bit. Look what I'm gonna do, guys, here. I want to check this bit. I want to check this bit, for example, as just an example. So what I'm gonna do, guys, the bit I want to check, I'm gonna put 1 under this bit. Then I'm gonna put 0 everywhere. Then I'm gonna use AND, logic AND. So to check some bits, the only way, or the easiest way to do it using AND, logic AND. So we're going to use logic AND to check some bits. Why? What is the logic? I'm going to tell you what is the idea here. The idea is that, look here, guys, because I put zeros here, and you know 0 and any bit is 0. Okay? That's why I'm going to get zeros here. I want to clear the bits I don't want to check. I want to clear them. Okay? So here, this is the result I'm going to get. So I'm going to get 0, 0, 0. Okay. And because I'm interested in this bit, I want to check this bit. I'm going to put here 1. So when I put here 1, I'm going to get this bit is going to come to here. So this bit is going to come here. So after I do this operation, look, guess what I'm going to get? I'm going to get the following. I'm going to get 0, 0, 0, 0, 0, 0, 0, and then bit 7. Is that okay? Whatever in bit 7. Is that okay? Now, how can you check? I'm going to tell you how I check. If this byte is equal to 0, what it means? If the value of the byte is equal to 0, what it means? It means bit 7 is 0. Otherwise, bit 7 is 1. You got what I'm saying? So that's exactly what I'm going to do. I'm going to get a byte, and then I'm going to check if this byte is 0 or not. Okay, so the way I'm going to do it, as you see here, guys, number 1, I'm going to do logic AND. If you want to check some bits, you have to use logic AND. That's number 1. Number 2, the bit I want to check, I have to put 1, and then I put 0 everywhere. Then the byte I'm going to get is going to be this way. And then after I do the AND operation, I can use branch if equal or branch if not equal. Why? Because if this bit is 0, I'm going to get 0 here, and then the result is 0. So the AND operation is going to set the 0 flag. Okay, so if this one is 0, I'm going to get 0 here, and because the result is 0, the AND operation is going to set the 0 flag. Is that okay? So all what I'm going to do after I use logic AND, I'm going to use branch if equal or branch if not equal. So this one is going to branch if the 0 flag is 1, which means bit 7 is 0, because bit 7 is 0. However, if you want to branch if bit 7 is 1, you have to use this one. Any questions? Again, look at the logic. Number 1, if you want to check some bits, the only one you have to use AND. Number 2, you have to select this number. You have to do AND with this number. In this number, I have to clear the bits I don't want to check. And the bit or bits I want to check, I'm going to put 1, as you see here. And then after this instruction, I'm going to check the 0 flag. What is the value of the 0 flag? Branch if equal, this one is gonna branch if the 0 flag is 1. And the 0 flag is 1 if the result is 0 or this bit is 0. Okay, so if bit 7 is 0, so this one is gonna be branch. Otherwise, if you wanna branch when this bit is 1, so the result is not 0. The 0 flag should be 0. So that's why you have to use branch if not equal. Any question? You don't need to compare. If you want to use compare, that's totally fine. If you want to get a number and then you want to compare this number to 0, it's totally fine. But actually, you don't need to compare. All what you need, you have to do AND. And this AND operation is gonna update the 0 flag. And then after that, you just use branch. You don't need to compare. But again, if you want to compare, it's okay, but it's redundant. Any questions? Okay, very important. We will do it all the time. So let me summarize what I said before I move forward. Very important. The summary, guys, is the following. Number 1. We have an instruction to do these logic operations AND or XOR. These logic operations are going to do bit by bit logic operations. Okay. This is number 1. I'm going to explain the instruction right now. Number 2, we are going to use this logic operation to do one of 2 things. We are going to do bit manipulation, or we are going to check some bits. In bit manipulation, it means I have a byte, I want to modify, I want to manipulate some bits, and I don't want to change the other bits. Okay. And in this case, you maybe you need to set some bits, you want to clear some bits, you want to flip some bits. Is that okay? How can we do that? If you want to set some bits, you have to use logic OR. If you want to clear some bits, you have to use logic AND. If you want to flip some bits, you have to use XOR. Is that okay? How? That's exactly what I explained here. So what I explained here, if you want to, the bits you want to clear, you have to put zeros in the position of these bits. In the bits you don't need to change, you put ones, and then you do AND operation. Okay. Set, in case if you want to set some bits, the bits you want to set, you put 1. The bits you don't need to change, you put zeros. And I explained why. Simply because 0 or any value, I'm going to get the same value back. 1 and any value, I'm going to get 1. Right? This is how it works. In case of, if you want to flip some bits, the bits you want to flip, you put 1, and the bits you don't want to flip, you put zeros, and then you do XOR. Okay. Number 2, also we are going to use logic AND, only logic AND. We are going to use it to check some bits, if some bits are ones or zeros. And the idea we will do it, guys, as I explained here. If you want to check, for example, this bit, the idea we're going to use, just the bits I want to check, I put zeros. The bits I don't want to check, I'm going to put, sorry, the bits I don't want to check, I'm going to put zeros, as you see here, because 0 and anything, I'm going to get 0. The bit I want to check, I'm going to put 1 here under this bit. Bit or bits, okay? In case of bits, so you have to use more than 1, right? So anyway, so, and then after that, after the end of instruction, I'm going to check the 0 flag, okay? If you want to branch, if this bit is 0, okay, so you have to use equal. If you want to branch, if this bit is not 0, you have to use not equal. Any questions? Okay, so now what I'm going to do right now, I'm going to do 2 things. Number 1, I'm going to teach what instructions we have for AND or XOR. This number 1. Number 2, I'm going to give you examples. Okay. So here, number 1, for logic, for AND, logic AND, we have only 3 instructions. We have AND register A to a memory location or immediate value. So here you can put any format for memory location I explained to you before, like 0, x, 1000, 1, x plus, or A, x, whatever. So any format for memory, you can put it here, or you can put immediate value. Remember, in case of immediate value, you have to put hashtag. Okay. So what this instruction is going to do, this instruction is going to do logic AND byte to byte A to the memory location or immediate value, and then it's going to store the result in register A, right? We have another one similar to this one, but for register B. Okay. We have another one, but for the carry flag, for CCR. That's all what we have. So you can do AND between register A and memory location or immediate value byte and byte. Then you can do AND register B and memory location immediate value byte to byte. Or you, and then this one for the flag register. That's all what we have. We don't have word, but still, even if you don't have a word, still you can do it. For example, what you can do, if you can put the word in register G, and register D, actually it has B and A. Is that okay? And then you can do AND here, and then you can do AND here. Yes, this can be separate operation. So you can do AND here and here, or here or here, XOR here and XOR. It can be separate because there is no carry. You remember before when we did addition or something, I told you it's not going to work, or in case of negate, it's not going to work because there may be carry. But in case of AND, just bit by bit, right? So you can do it separately. Yes. Yeah, what I mean here. So register A is a byte. Is that okay? Register A is a byte. So here I'm gonna do it, for example, with immediate value, like 10111110. Okay, that's what I mean. So here I'm gonna do bit by bit for byte and byte. You got what I'm saying? This what? No, this AND, logic AND, bit by bit, logic AND. Logic AND, bit by bit. You know what I'm saying? Bit by bit, bitwise. So when for example, here, let me give you an example. For example, if you have 1, 1, 1, 0, and then 0, 0, 1, 1. Okay, so 1 and 0, the result is 0. 1 and 1 is 1. 1 and 1 is 1. 1 and 1 is 1. This is what we call it logic, bit by bit logic. Okay. So here for OR, guys, for OR, it's exactly the same thing. So you can do OR, you can do OR for register A, memory location or immediate value, byte and byte as well. Okay. Or you can do OR with register B, right? Or you can do OR for flag register. We don't have a word, but it's not a problem. Why? Because for a word you can do OR for a byte and then OR for a byte. It's okay. You can make it separate. It's okay. However, for XOR, we have only 2 instructions for XOR, as you see here. One for register A, the other one for register B, but we don't have one for flags. Okay. Any questions? So we don't have many instructions, as you see here. Any questions? Great. So now let's have just examples. I'm going to give you examples just to better understand what I explained here. That's all what I'm going to do. Then only example. After that, I'm done with this section. We have many examples here. So let's start with the first example. Look here, guys. I want to clear the upper 4 bits in the byte 56. So this is the address. So in the byte in the location 56 in this byte, I want to clear the upper 4 bits. Is that okay? So in this byte, in this location, I want to clear the upper 4 bit. I told you today, if you want to clear some bits, you have to first, if you want to clear, you have to use logic AND. Clear, you have to use logic AND. This is number 1. Number 2, what number I have to use here? Very simple. So the number you have to use here, guys, the bits you want to clear, I want to clear these bits. Okay, the upper 4 bits. So you have to put here 4 zeros. The bits you don't need to change, you put 1s here. Okay, so that's exactly what I'm gonna do. So I need the byte in this location. I have to do AND, logic AND with this number, and then I have to store the result in the location 56. Is that okay? But we have a small problem here. The problem we have here is, can I do AND, logic AND between a memory location and immediate value? No, we don't have this instruction. We don't have this. It has to be done through register A, right? That's exactly what I did. Look here, guys. Number 1, I'm gonna read the byte as you see here at the location 56. Number 2, I'm gonna do like AND. I'm gonna do AND with this number 000111 this way. Is that okay? And then the result is in A, so I have to return back the result to 56. Any questions? So number 1, I have to read the byte. I'm gonna put it in register A. Then I'm gonna do the AND with this number. Okay. So what I'm gonna get after this operation, I'm gonna get the same value, the same byte in this location, but these 4 bits are cleared, and these 4 bits are no change, right? Then I'm gonna return it back to 56. Any questions? Yes. No, you don't need. You don't. So you can. Yes, that's what I'm saying here. Look here. You can put this way, or you can put here $sign 0F. So this one is okay. This one is okay. But you again in both cases you have to put here hashtag in the beginning. Any questions? Okay. Good news. The good news is you can do it this way. You can do it this way, or you can do it using only one instruction. I love this instruction. You can do it all you can just use this instruction all the time. I love it. Why? Because just look here, just for short. Instead of using 3 instructions, I'm gonna just use 1. So this instruction is called, as you see here, guys, bit clear. Bit clear. So we have an instruction to clear some bits. It's called bit clear, right? And then here you have to put the address 56. And then here you have to put a mask. In this mask, you have to tell me which bits you want to clear. Which bits you want to clear. And the bits you want to clear, you have to put once in the location of this bits. So this instruction, again, this instruction, guys, It's called bit clear. And this instruction, number one, you have to give me the address of the byte I have to work on. Number two, you have to give me a mask. In this mask, you have to tell me, you have to mark the bits you want to clear. You have to tell me which bits you want to clear. You have to do that by putting ones here. Okay, so again, this instruction is going to do the same thing like this for instruction. But I suggest, or it's much easier, you can just use this instruction all the time. There is something very confusing to the students here. Please listen to me. Very confusing to students. Look here, guys. Here, the number I have to select here, I have to select a number so that I have to put here zeros to clear these bits. And the bits I don't want to change, I have to put ones because this is how logic AND works, right? But this one, I'm not doing logic AND here. This is a different one. This one is gonna clear some bits, okay? So I'm not doing logic AND, okay? That's why here is a mask. In the mask, you just put, you need to only to mark. You need to mark the bits you wanna clear. That's why here, the bits you wanna clear, you have to put one. You have to put one. What I'm saying here, guys, because this confusing students, listen to me. Here, if you use this instruction, I'm gonna use this number. However, if I use this one, I'm gonna use this number. Why these two numbers are different? Why they are different? Simply because what I'm doing here is different from here. What I'm doing here, guys, I need to mark, I need to tell the instruction which bits I want to clear. In order to mark these bits, I'm going to use ones. So here I use 1, 1, 1 because I'm telling this instruction, please, I want to clear these bits. I'm not doing AND operation here. Here I'm just telling the instruction, I want to clear these bits. But here I'm doing AND operation. And I know in case of AND operation, if you want to clear some bits, you have to put zeros. And if you don't want to change, you have to put ones. Please don't be confused. In my opinion, if you can just use this one all the time, but still you need to understand how I can use AND, how logic AND operation can be used to clear some bits this way. But I think it would be easier if you just use this one all the time. Okay, guys? Any questions? Thanks.